Welcome, students, to Flip Thursday. Today, we are going to be looking at lesson 1.04, and we're going to go through this lesson. The intent for this lesson is for you to watch this video before class. So if you did not in the future, please make sure you're watching this either on Wednesday or the morning before you come to class. You could watch it, between classes or during lunch before class if you have that as an option. But please watch it during that time. Please try to complete as much of the study guide as well. Before you come, we will have some time to work on the study guide before we start working on the lesson. But to have enough time to be able to do both, you might be a little tight. Make sure you have downloaded and opened your lesson 1.04 study guide. Please complete that as we go along. A lot of this work we're going to talk about today. Some of the things in class we will work on as far as some examples, but there are things on here you are going to be expected to do yourself from what you have learned. I'm asking you to participate as we go along. With that said, let's go ahead and let's get started. So let's start off with the first thing, and that is today we're going to talk a lot about how to locate things on the surface of the earth. And a lot of you are probably like, well, why is this important? It's important because we are going to be talking about locations. History is intimately connected to land, and it's intimately connected to locations on the surface of the earth. And there may be times where we're talking about a specific place, and we will refer to that location. In some cases, referencing it by map, and sometimes to get you to that, we might use latitude and longitude. Now, we're going to be talking today about latitude and longitude, a geographical coordinate system that helps to, locate things on the surface of the earth. And when we talk about that, we're talking about a coordinate system. It is a grid system, and by that meaning, it makes a man-made grid that does not show up on the surface of the earth, but that we can kind of superimpose on maps and things like that to be used as a tool. It is a grid system formed by lines of latitude and longitude. In a way, it's very similar if you're really familiar with math or really love math, like the Cartesian coordinate system, but this is a little different. Works in a very similar way. Now, the coordinates are done usually by latitude and longitude. So location always is determined by latitude and longitude. All right, so let's go to this video here real quick, and we'll be right back, and we'll wrap up this lesson.
Hey Brain Stuff, I'm Jonathan Strickland. So you've probably seen geographic coordinates like these before, maybe on a GPS device or maybe scrawled in a mysterious note you found in the glove box of a rental car. But if you never knew exactly what they meant, fear not. It's actually pretty simple, and we are here to make it all clear. When you see a set of geographic coordinates looking like this, or like this, you're reading latitude and longitude. Latitude represents north-south location, and longitude represents east-west location, usually listed in that order. By combining them, you can pinpoint any spot on the surface of the Earth. These coordinates aren't expressed in units of distance, but in degrees. Why? Because the Earth is a sphere. Imagine a line running from the equator to the center of the Earth, and then another line running from the center of the Earth to the north or south pole. These two lines make a 90-degree angle. All latitudes in each hemisphere can be represented by drawing a third line somewhere between them. So the equator would have 0 degrees latitude, and the North Pole would have 90 degrees north latitude, and a location halfway between the North Pole and the equator would lie at 45 degrees north. Same thing for the southern hemisphere, except you'd call it degrees south. For more precision, each degree of the Earth's surface is divided evenly into 60 minutes, and each minute is divided into 60 seconds. If you need to get even more specific, you can just add decimals to your seconds. Alternately, you can write the whole coordinate in decimal notation. To do this, you have to convert minutes and seconds, which are base 60, into our regular base 10 counting system by dividing each unit by 60 and then summing them up. The results sometimes look counterintuitive, but if you're skeptical, you can pause the video and check out the math. Lines of longitude, also called meridians, run north-south and are used to measure position along the east-west axis. While the lines of latitude run parallel to each other, meridians converge at the poles and spread farthest apart at the equator, like the segments of an orange. Longitude is also measured in degrees, but its 0-degree line is known as the prime meridian, and it runs from the North Pole to the South Pole through Greenwich, England. So, if the prime meridian is 0 degrees, the opposite side of the Earth is 180 degrees, and lines in between are expressed as degrees east or degrees west, between 0 and 180. Since the lines of latitude are parallel, each degree covers about the same distance the world over, roughly 111 kilometers. But because meridians converge at the poles, the distance covered in each degree of longitude varies hugely depending on your latitude. At 20 degrees north, which is about the latitude of Cuba and Hawaii, 1 degree of longitude is approximately 104 kilometers. At 80 degrees north, the latitude of Svalbard and northern Greenland, it's only about 19 kilometers. So, let's say I wanted to go dig up a stash of hot loot from some coordinates I found written in a mysterious note. Even without looking at a map, we can start to make a guess where this would be. Since it's 43 degrees north, it's almost halfway between the equator and the North Pole, again halfway being 45 degrees. And since it's 89 degrees west, it's almost halfway west between the prime meridian and the opposite side of the globe, halfway being half of 180 degrees or 90 degrees. Based on this alone, you can guess it's probably somewhere in North America. But if we use a map or a digital tool like Google Earth, we can zoom in and see these coordinates lead us to the U.S. National Mustard Museum in Middleton, Wisconsin? Huh. Well, what's the weirdest landmark you've ever found on Google Earth? Paste the coordinates in the comments so everybody can check it out. If you like this video, hit that thumbs up button and subscribe for more. And as always, for answers to
about how to use latitude and longitude. Now, ladies and gentlemen, let me just tell you that when you are looking at latitude and longitude, if you go outside and you're walking along, you are not, and I repeat, not going to see these lines on the ground. These are fictitious lines that we artificially create for maps and globes and stuff like that that help us to determine things. So let's make sure that we kind of cover a few things that you really need to know. Everything is going to start with the first line of latitude, and that is the equator. What we want to determine is the equator at 0 degrees, whether we're going to go north of that point or whether we are going south of that point. And usually when you look at a coordinate, it's going to say 45 degrees, let's say north, or 45 degrees south, or 33 degrees south, or 27 degrees north. And it tells you whether you're going either up, north is up, and south is down. Latitude lines. Latitude lines are the measure of location north or south, and they are expressed in these lines that are going like this. All right. Just like that. So those are lines of latitude. Think about them. They are flat, kind of like a table. So latitude is flatitude. It's a good way to kind of remember it. Now, longitude lines run up and down. They are vertical lines, and they are lines that literally are like segments of an orange. If you ever peel an orange and you pull a piece out, kind of like that, right? So a longitude line is artificially starts at Greenwich, England. We said that Greenwich, England is 0, and we'll have a map here in a moment that we'll look at where we'll see the line, the prime meridian, come through. Lines of longitude actually get closer and closer together at the top and at the bottom of the globe, where lines of latitude stay the same. These are actually also known as parallels. Latitude lines are known as parallels because they stay the same distance apart here and here and here and here and here as they do anywhere else, where the lines of longitude are different. So lines of longitude, you would literally start at 0 degrees, which runs through Greenwich, England. And if it says, say, 80 degrees west, then you know you're heading this direction. If it said 27 degrees east, you're going to head this direction. So either left or right of the prime meridian. So you always start with lines of latitude first, and you go to longitude second. All right, so the equator, again, equator is a line of latitude or a parallel, because these lines, as you see here, run parallel to each other. They go the same distance, and they never get closer and closer to each other. They will run in an east-west direction. So east is over here, west is over here, and you'll notice that the equator runs from east over to west, and so do the other lines here as well. Now, the equator literally is going to evenly split the Earth in half. It is labeled as 0 degrees, and this is our starting point when we look at trying to determine a location. The prime meridian going through Greenwich, England, which is right here, is a line of longitude. It is also known as a meridian. In fact, all of those lines are known as meridians, which is why we call this one the prime meridian, or the one that we start with, and they run north-south. Now, the prime meridian is the line of longitude that is labeled as 0 degrees. So remember, we start with the equator. We look at the things. If it says, 27 degrees north, we know we're going up. If it says, say, 40 degrees south, we know we're going south, so we're going down. And then we look at the next number, and the next number will either say east or west, and that will determine whether we go left or right. If it's a west number, then we're going to go to the left. If it is a right number, then we're going easterly number, then we're going to go to the right. It's just that simple. Anything east of the prime meridian would be east longitudes. That's everything in here. Anything that's west would point to west longitude. East longitudes are over here. West longitudes are over here. With the equator, you have the northern hemisphere up here, and you have the southern hemisphere here. I apologize there. So let's do a little practice, and this is where things can be very, very fun. Use your tools. Whenever you look at a map, you have to determine what the number of degrees are between these. So here is 45. Here is 50. We know there are 5 degrees between meridians here. Is it the same up here? We have 0 degrees and 5 degrees. So we have 5 degrees here as well. That's important for us to know. That means that there will be 4 equal segments between each line. Now, sometimes it might be 0 degrees, and it could go in 2 degree segments, for instance. Sometimes it might be 10. It really, really just depends. So we're going to look for the first one here, and that is Bordeaux, France. All right, Bordeaux, France. So we're going to look at the map here, and we're going to find Bordeaux right here. Now, one of the things that's interesting is we're looking at a map. We don't have the ability to very easily get a very specific or exact number. So don't panic. Don't freak out. You'll notice that 45 degrees north. Remember, we always go up or down first. We know that Bordeaux is right here near the 45 degree line. So it's going to be approximately, and this is the thing to use for approximately, say 45 degrees. It's actually a little under. It's probably more like 44.8 or 44.9 degrees, as they said in the video. And of course, remember, we are saying it is approximately, that's this little squiggle means approximately 45 degrees. We're going north, so it's got to be north. All right, 45 degrees north. Now, what we got to do is figure out which direction we're going. Well, here is the prime meridian. Greenwich, England would be right up here. So if we go down, down, down to this point right here, you'll notice it is to the left of this line. That means that we are going to the west, and you can check that. Here's 5 degrees west. Over here is 5 degrees east. So we're going to go west. So we know instantly that anything we write in for Bordeaux, France is going to be something west. So go ahead and put the W down. You know that. Now, we're going to look at this. We know, for instance, that if we divide this up, we have 5 degrees here. We have 0 degrees here. If we try to make this roughly equal, we have 1, let's say 2, let's say 3, let's say 4 lines in here. And if we kind of draw this line down, 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 you'll see that it's going to be somewhere in there, right? I probably didn't draw that line real right. I'm going to actually say, because it gets a little wider as you go down, that this line really should have been closer. So I'm going to say it's somewhere between, say, 1 and 2 degrees. And let's just say 2 degrees to be safe. Okay. To be really safe here. So if we actually look up the line, well, no, you know what? I said this was 1. Let's go ahead and just call it 1 degree here. So if we actually look up the calculations for Bordeaux, Bordeaux is actually literally approximately, meaning exactly 44.8378 degrees north. So we are close-ish there to this. Close to the 45. It's 44.8, so we could round that up. And it's exactly 0.5792 degrees west. So we're going to round that up. And since we're on this map, we'll just call it 1 degree west. Now let's look for Paris. Paris is here. Hopefully this one will be a little easier. We notice that we're already north of the equator. It's north here. It's north here. So we can write north here. And we look at the prime meridian here. We see that we're going to be east of the prime meridian. East here. It's going to be east here. So we can write those two down. That makes it easy. We know we're at 45 here. We know we're at 50 here. If we do the subdivisions, we know there's 5. We just go 1. We go 2. We go 3. We go 4. We know we're going to be somewhere between 46, 47, 48. And 49 degrees in here somewhere. So it's going to be closer to 49, but not exact. So we could say 48.5 degrees, I think is what I would choose here. So 48, you could put 1.5 or you could put 0.5, either one. And then let's look. Here's the 0 degree. We've got literally 1. We've got 2. We've got, whoops, this is not probably as equal as it should be. 3 and then 4. If we draw our lines down here, this line is going to come really, really stinking close. And this one's going to come a little further to the west. Part of me would say it's about 2.5, maybe 2.5 degrees here, because it is right between the 2 and the 3. So let's just say 2.5. We'll guesstimate it here, an accurate guesstimate. And if we actually look it up, it is literally 48.85 degrees north and 2.35, so just under half, east. And so we are really, really close. So that's essentially what you're doing is you're drawing a line. You're drawing a line. Let me grab my pens here. You're drawing a line saying from here over and from here, whoops. I wish this thing would allow you to draw straight lines from here over, and that's exactly where it is. Now, if we identify the following cities using latitude and longitude, we got to find 48 degrees north. Well, here's 45. Here's 50. 48 is going to be somewhere like right about here. Okay. And we want to find 2 degrees. Well, here was 1 degree. Here's 2 degrees. And if we follow this over something like this, the closest city here would be Orléans. All right, so Orléans. If I could type it there correctly. There we go. And the next one, 47.5 degrees north. So 47. So here's 6. Here's 7. And if we take that line and we kind of transcribe it back and forth here. So here's 6, here's 7. All right, that's 47. And it says 47.5. So we're going to be a little further north. And these lines are not real specific. Obviously, the other line would be somewhere up here. So you can already tell pretty quickly that there's only one city that's really up this way. If we look at 5, it says 5 degrees east. Well, here's 5 degrees east, and here we go. So we are looking at a place here called Dijon, France. So if you want to know where Dijon mustard comes from, guess what? You're at the home of Dijon mustard. So that's how you're going to do your activity on your study guide. When you get to it, you're going to have your own places. We've given you a much easier map to use, so I hope you're happy about that. So let's talk about the last one. That is two types of location descriptions. One is relative location. It has nothing to do with a member of your family, but it is a description of generally where you are. Like, for instance, I live, let's say, near Cleveland. All right, that's very general. It doesn't say exactly where I live. I just said I live near Cleveland, or I live in Northeast Ohio. Absolute location can actually be several different things. Absolute location is the exact location, typically latitude and longitude, but you could also use a street address as well. I live specifically at 444 South Main Street, or I live at 43 degrees north, 27 degrees west. And then you can locate that right there. And that is literally my absolute physical location. That's where the exact location where I'd be. So if you look at some of these examples, for instance, this is an address. Addresses are by definition an exact physical location. So it is an absolute location. But if I said I live 5 blocks west of Citizens Bank Park, I'm not telling you exactly. I'm just giving you kind of a general area. If I say that the city of Philadelphia is 40 degrees north, 75 degrees west, that is an absolute location. But if I say I'm somewhere around the corner from this bank, that is a relative location. And if I say that St. Louis is in eastern Missouri, again, that is a relative location. So, question for you to think about as we wrap things up. Would Northwest Ohio be an absolute or relative location? All right, well, we have finished up this lesson for today. When you come in tomorrow, make sure you've already completed this. You're going to go through. If you have anything to finish up, we'll do that. And then we're going to have a couple activities with latitude and longitude. We're going to talk about a few of these things. And hopefully you've enjoyed your first Flipped Thursday. Have a good day.